All right, here's another short video on logarithmic differentiation, and this is for the second type of functions where you have things like x to the x. So you have x's in the base and you have x's in the exponent. The only way you can find these derivatives are using logarithmic differentiation. Common mistake is they treat it like x squared or x to the fifth, something where it's x to the n. And they'll say y prime is x times x to the x minus 1. This is wrong. You cannot use the power rule. No, you can't put x in front and then subtract 1. This is only good if the power is a constant, not if it's a variable. So we can't do that. Let me clear this and start over. So we're going to do the same thing we did before, and you want to take natural log of both sides. So ln y is equal to ln x to the x. And the reason we want to do this is because when you're doing the, when you have the natural log of a to some power, this is equivalent as you can take this power and you can put it in front. So this is equivalent to x times natural log of x. So then when you want to go find the derivative, do the same thing we did before. Find the derivative of both sides with respect to x. So this side always gives you 1 over y prime, always, always, always. And then over here you're going to use product rule. And so there's your u. This is your v. So your u is x, your u prime is 1, your v is natural log of x, your v prime is 1 over x, and so it's just u prime v plus uv prime, so it's 1 times natural log of x plus u times v prime, and this simplifies to natural log of x, and x times 1 over x simplifies to 1, and now you can multiply both sides by y, so natural log of x plus 1 times y, and then y is x to the x, so you want to make that substitution, and I'll put it at the front, x to the x times natural log of x plus 1, and there we go. And that's your final answer. That's the derivative of x to the x. It's x to the x times natural log of x plus 1. Let me do another one. Let's do y is equal to sine of x to, let's go to the square root of x. Doesn't really matter. So we're going to do the same thing. Notice I have x's in the base and x's in the power. And so natural log of y is equal to the natural log of sine of x to the square root of x. Now I can use the rules of logs that says this power can be put in front. So this is equivalent to square root of x times ln of sine of x. And so now I'm going to take the derivative of both sides with respect to x. Do this both sides. So the derivative of this is 1 over y times y prime, chain rule, don't forget chain rule. And then this side I need to use product rule. So u is square root of x, u prime is 1 over 2 root x, v is ln of sine of x, v prime, you need sine of x in the denominator, and the derivative of sine of x, which is cosine of x, so that's cotangent of x. So now I want to use product rule, u prime v, u v prime, so u prime, 1 over, over 2 square root of x, that's u prime, times v, which is ln of sine of x, plus u, which is square root of x, times v prime, well this is just cotangent x, and then my last step is to multiply both sides by y. So y prime is y times, and then I'm just going to clean this up, this is ln of sine x all over 2 root x plus square root of x cotan x, and then now you need to replace y with what it's equal to. So this is sine of x to the root x times this whole thing right here, ln sine of x all over 2 square root of x plus square root of x times cotangent x. And that's my y prime. And this is logarithmic. Let me do one more quick one. And let's do, how about y is equal to 2 to the x? So let me do the same thing I did before. I have natural log y is equal to natural log 2 to the x. Just took the natural log of both sides. Then I can use the power rule and I can put it in front. So this is equal to x times natural log of 2. Now natural log of 2 is just a constant. So this is just like saying 3x or 6x or half x. This is just a constant. So I'm going to find the derivative of both sides with respect to x. So now the derivative of this side with respect to x is 1 over y prime. And this is just a constant times x, so its derivative is just natural log 2. If you need help, remember the derivative of 3x is 3. The derivative of 1/2 x is a half. So the derivative of natural log of 2x is natural log of 2. That's just a little side note in case you had forgotten when you're finding derivatives. This is just a constant times x. Little side note. Okay, let me get back to this problem. So I have 1 over y prime is equal to the constant natural log of 2, so y prime, multiply both sides by y to cancel it out of that side, and y is just 2 to the x, so this is just natural log of 2 times 2 to the x. So you can do logarithmic differentiation for exponential functions that aren't just e to the x. And those are some 3 quick little examples.